Okay, so our x-intercept point, we have x is going to be equal to -5 when y is 0. All right, we plug 0 in here for y, and x is -5. So let me go ahead and write that point in. So -5, 0. And that's we're going to say that that'll be right here. How's that? So we have it in our picture. Okay. Alright, now let's find where the graph crosses the y-axis. And so that's going to be the y-intercept, and we want to find that y-intercept point. Okay, so I'm going to rewrite this. This is x plus y greater than or equal to -5. Alright, where it crosses the y-axis, this is when x is 0. And we want to know what is y going to be. And it looks like y is -5 also. So we're going to put -5 right down here. Okay. So we're looking at a line that's passing through both of these points right here. Okay. And it's in standard form. We want to pick a point, just pick somewhere on the line right here. Now, which way is it going to be shaded? This direction or this direction? Well, all we got to do is look at this guy right here. Okay, and it's pointing to the right. So it's pointing over here. So that means that every single point on this side of the line, all right, is going to make this true. So let's just pick a point, and of course an easy one to pick is the origin. If I plugged 0 and 0 into this, so 0 plus 0, is that greater than or equal to -5? Yes, 0 is greater than or equal to -5. So it's like if you just if you chose a point and you plugged it in over here, if it makes it true, then you know that every single point on this side of the line is going to also make this true. But I like to look at it this way, where I put my cursor on it. Which way do I go? Over here, over there, right? Depending on what this looks like. Now, the key is that this must be in a standard form, which I'm calling this to be a positive coefficient right here. It doesn't matter if this is negative or positive. It doesn't matter. This is what matters. If this is negative or positive, we want it to always be positive. You see, it was negative up here, but in order to get rid of this negative, we just multiplied through by negative all the way across. But when we do that, we have to flip this inequality here. Okay. So anyway, it looks like that everything on this side of the line is going to be, all the points on this side of the line, including this line, right, including a point on the line, will make this true. And we have to choose every point on the line because, look, we're including this. This is greater than or equal to. This is the equal to sign, which means we include that. Okay? So it's real simple. We make sure we get it in standard form. We find our x-intercept or y-intercept point, right? Just kind of pick a point here and then draw a line through the 2 points, and then we determine which side of this line needs to be shaded, left or right, or however you want to look at this, up or down. Okay, I'm looking at it left to right because of this guy right here looks like the head of an arrow and it's pointing to the right, which means everything to this side of the line needs to be shaded. Okay, well, let's look at a couple more. Now the question is, when will you ever see this again? Well, if you ever take finite math in college, you'll be doing lots of this. And of course, if you take college algebra, you might be doing this also. Okay, let's do this. How about -3x plus y is less than, let's say, 4. Okay, so step 1, let's get this in standard form before we do anything. That means we multiply through by a negative all the way across. So I'll just bring this down right here. So we want to make sure that we multiply this by a negative to both sides, -1 to both sides, right? So it's going to make that a 3x minus y is greater than